Lecture 25, time constant, rise time and fall time. So capacitor charging and discharging is not instantaneous, and the voltage and current changes exponentially with time. So this lecture tries to explain what controls the speed of these changes, what is time constant, and what is rise time and fall time. So let's start with time constant. So for an RC circuit, time constant is simply R into C, that is resistance value in ohms into capacitance value in farads. So we know that capacitor voltage charging equation is simply Vc is equal to V1 minus e raised to power minus t by Rc. So the final value of this equation comes when t is very large, that is almost infinite. So Vc becomes equal to V into 1 minus e raised to power minus infinite, which is simply V into 1 minus 0, which is V. So the final value is V, and when I put t is equal to tau, that is Rc, in this equation, we get Vc is equal to V into 1 minus e raised to power minus 1. Since E is 2.738, so Vc comes out to be 0.632 times of V, and V was the final voltage. Therefore, we can say that at time t is equal to Rc, the capacitor voltage rises to 63.2% of the final voltage. And similarly, the discharging equation is Vc is equal to V naught e raised to power minus t by Rc. So when I put t is equal to 0 in this equation, it becomes V naught e raised to power 0, that is simply V naught. Therefore, the initial voltage is V naught. And when I put t is equal to Rc in this circuit, I get Vc is equal to 0.368 of V naught. So that means that when time is equal to time constant, that is Rc, the voltage falls to 36.8% of the maximum value. So this is time constant, which gives you an idea about rate of rise or fall of capacitor voltage. This can be further understood by these three values. So if time is equal to one time constant, that is 1 Rc, we see that the voltage rises to 68.3% of the final value. But when I put t is equal to 3 Rc in the same equation, that is 2 Rc, 3 Rc, we see that the voltage has risen to almost 95% of the complete value. So this is almost 95%. And when this time becomes equal to 5 times of Rc, on solving the equation, we get Vc is equal to 99.3% of the final value, that is V. So we can say that at 5 times of Rc, the voltage almost reaches its maximum value. Let's move on to rise time. So rise time is simply the time taken by the capacitor to rise from 10% of the voltage to 90% of the final value. So time taken to go from 0.1 to 0.9 V is known as rise time, which is roughly equal to 2.2 times of Rc. Similarly, fall time is the time taken by the capacitor to go from 90% of the initial value in discharging to 10% of the initial value, and the time taken for that is known as fall time, which is also equal to 2.2 times of Rc. So rise time and fall time basically helps determining speed of the electronic system, switching behavior, and timing and delays in the system.